Algebra 2 Honors 7.3 notes, and we're going to do multiplication and division of rational expressions. And I guess I kind of look forward to this lesson just because it has factoring in it, and when you can factor, it makes things a lot easier. And I know that some of you need to work on that, so it's going to be a good lesson. So we're going to simplify rational expressions. So what is a rational expression? It's a fraction whose numerator and denominator are non-zero polynomials. You have a polynomial over a polynomial. Excuse me. And the domain is going to be all reals except for what makes the denominator 0. And you're going to be simplifying these. And it's in simplified form when its numerator and denominator have no common factors other than plus or minus 1. And so simplifying, here's this property. You have two things multiplied, and that's important in the numerator, two things multiplied in the denominator, but one of those things being multiplied is the same in the numerator and denominator, and you can cancel them. So they have this example where they, have times 5 in the top and bottom, so they just cancel those. That leaves 3 over 13. But what they did is they took 15 and factored it to 3 times 5, and they took 65 and factored it to 13 times 5. And then they could see that they had that common factor, and you could cancel. Well, now you're going to do it with polynomials. You're going to factor the polynomials into expressions all being multiplied. It's important that you understand the 4 is times that quantity, the x plus 3 is times the other quantity, x plus 3. So it fits this kind of scenario where you have two things multiplied in the numerator, two things multiplied in the denominator, and therefore you can cancel the factors that are the same and end up with 4 over x plus 3. So let's look at this in example 1. And so you need to start by work down the page in columns and write the original problem and start each new line with an equal sign. And so we have that written down, and then the next line is we are going to factor. The numerator and the denominator are both quadratics. Two numbers that multiply to be negative 12 but add up to a negative 1 are going to be an x minus 4 and an x plus 3. And in the denominator, we have a difference of squares. It factors x plus 3 and x minus 3. And so just remember, a squared minus b squared factors a plus b, a minus b. And so that's why x squared minus 9 factors to x plus 3, x minus 3. Now you have two things being multiplied in the numerator, two things in the denominator being multiplied. And so this quantity cancels out this one, and you're left with x minus 4 over x minus 3. So there is an exception that there's something we've lost. In the original problem, x cannot be plus or minus 3 because either of those will make the denominator 0. But when I look at this fraction right there, I can see that x can't be positive 3, but I've lost x being, that x can't be negative 3. So, just erasing that, I need to include x cannot be negative 3. In addition to it can't be positive 3, but we can see that by looking at that. I would accept if you wrote x cannot be plus or minus 3, that's fine if you put both of them down, but you have to say that x can't be negative 3, or you don't have the same intent that the original problem had. So there is our answer. So you try it. Pause the video, see if you can do the next one. Let's see how you did. So the numerator is going to factor, the denominator is going to factor, and the numerator factors x minus 3, x plus 1. And you can have it x plus 1 times x minus 3. It's the same thing. They can be changed in order. And in the denominator, you have an x minus 3 and an x plus 2. So the x minus 3's can cancel, and you have x plus 1 over x plus 2. But we lost the fact that from the get-go, because of the way this factors, x can't be 3 and x can't be negative 2. It can't be either of those. Well, when I look at this simplified expression, I can see the denominator. I can't let x be negative 2, but I've lost that x can't be 3 either, so I need to name that. All right, so this next one, if you multiply fractions, so here we see if we have multiply fractions, you multiply the numerators, you multiply the denominators, and then you simplify if possible. And they show this in this example where they multiply the numerators, getting 30x cubed y cubed over 20xy cubed in the denominator, and then you need to realize that there's some things that cancel. So they factored out the numerator, 10 times 3 for 30, and they wrote it x times x squared because there was an x in the denominator that the x can cancel out with. So those are going to cancel out. And then the y cubed, they're going to just cancel with each other, so they canceled those. And you get 3x squared over 2. But notice how they qualified. X can't be 0 and y can't be 0 because in the original problem, we had x's and y's in the denominator, but in the simplified problem, they weren't there. So you have to qualify that x can't be 0 and y can't be 0. And so we're going to simplify. Oh, I skipped over. Oh, no, there we are. We're just ready for example 2. Now, I wouldn't necessarily multiply the 6 and the 9 out and then factor it. I am just going to take x squared times x to the 5th. Remember to write the original problem down. And when you take x squared times x to the 5th, you add exponents, you can get an x to the 7th. And the 6 times 9, I'm just going to leave them as times each other. And for the y's, I have y to the 1st times y squared, so you add the exponents and you get y cubed. In the denominator, I'm going to leave it 3 times 2, and then you have a times at x, and y cubed times y to the 1st is a y to the 4th. So now when I go to simplify this, 3 goes into 6 2 times. And then this 2 can cancel with that 2. In other words, the 3 times 2 produces 6 in the denominator, which cancels with the 6 in the numerator, leaving you with 9. And then you subtract exponents. So you have x to the 7 minus 1 when you have like bases and you're dividing. So you get 7 minus 1 times y to the 3 minus 4, which leaves you with 9x to the 6th and y to the negative 1. And then we write that with positive exponents and make it 9x to the 6th over y. Now there's some other ways to do this. You could take a different route here. Once the 6's cancel, and you could write it as 9 times x to the 6th and times y cubed. And the bottom, you could write it x times y cubed times y. So you've got them kind of how they did in their example, and then this x cancels this x, and this y cubed cancels this y cubed, leaving you with, didn't work out, let's try this again, leaving you with 9x to the 6th over y. So there's some different ways that you can format that, but you need to show steps. All right, so in example 3, it says find the product. Well, we're going to factor terms. And so in the first fraction, I can take out a 5x, and I get a 1 minus x. And I'm just going to be multiplying these, so I'm just going to extend that fraction bar. The second numerator is x squared minus 5x plus 6. That's going to factor x minus 6x plus 1. In the denominator, the x squared minus 4x minus 3 factors, and it is going to be an x minus 3x minus 1. And it's times 5x, so I'm going to put that out in front, but it's going to be in the denominator. Make sure your fraction bar is long enough there. Now I have 4 things being multiplied in the numerator, 3 things being multiplied in the denominator. Are any of those the same? Well, 5x's cancel. And, wait a minute. This 1 minus x is close to this, but it actually is not the same. Oh, oops, I gotta back up. I made an error. Silly me. X squared minus 5x plus 6. It's a positive 6, not a negative 6. My fault. Embarrassing. It factors x minus 2, x minus 3. I wasn't paying attention to the positive 6. So they both need to be negative, but add up to negative 5. So there we go. That's better. So that means not only do the 5x's cancel, the x minus 3's will cancel as well. But I still have this dilemma of 1 minus x over x minus 1. They are not the same. But when you have two things that are being subtracted but are in the opposite order, what I can do is I can take out a negative out of the numerator. Or I could do the same thing with the denominator. Notice if I redistributed that negative, I'd be back to a positive 1 minus x. So those, from this step to the next one, they are the same. And then I can write that as a negative x minus 1, just change the position. And then this as a factor cancels this, and you get a negative 1. And that's going to happen pretty much any time. If I have an a minus b over a b minus a, it's going to be a negative 1. I have 2x minus 3y over 3y minus 2x. They're being subtracted, but in opposite orders. It's going to simplify to a negative 1. And so here I have 1 minus x over x minus 2 all over x minus 1. And when these two cancel, I'm going to need to make it times a negative 1. And so I get a negative 1 times x minus 2, or a negative x plus 2. Now, I need to go back and look at the original denominator and realize that the domain is all reals except 0, 3, or 1. Because I can't divide by 0, and those numbers would make the original problem have denominators of 0. So when this simplifies to a minus x plus 2, and I no longer have any variables in the denominator, you have to state x cannot be 0, 3, or 1. All right, let's look at example 4. And this brings back a fun factoring thing. And I'm going to come up above, and I'm going to use this space to talk about it. So I have a cubed plus b cubed. When you have a sum of cubes, it factors into bi, tri, SOAP. a binomial times a trinomial. Binomial has the same sign. In the trinomial, you have an opposite sign, and the last term is always positive. This factors into a binomial times a trinomial where you have a squared, the opposite sign, and the product of a and b, and then that last term is always positive and it's squared. So a cubed plus b cubed factors into a binomial times a trinomial. This is something now that we expect you to remember. A cubed minus b cubed factors into, has the same sign for the binomial, and then a squared, the opposite sign of the binomial in the middle, and the last term is always positive. So you need to remember how to factor sums and differences of cubes. And that will be in your homework as well. So on this one, I'm going to just write it. I'm going to take an extra step here and just write it. Oops. X minus 7. This can be thought of as over 1. So x minus 7 times x squared minus 2x plus 4 all over this x cubed plus 8. I'm just going to write it like that to begin with. So I see the denominator. Oh, that is that sum of cubes. And if I start trying to factor this x squared minus 2x plus 4, I can't figure out anything that multiplies to be 4 that will add up to a negative 2. So you can check out from the quadratic formula the discriminant, which is that b squared minus 4ac, and check out the value of it. That's a negative 2 squared minus 4 times a 1 times a 4. And that's going to be 4 minus 16. And the point is it's negative, which would lead to imaginary solutions. So that also tells me x squared minus 2x plus 4 is not going to factor for me. So I'm going to just leave it x minus 7 times x squared minus 2x plus 4 and work on factoring that sum of cubes. Binomial, same sign, it's addition, so it's x plus 2, times a trinomial. You square the x, you take the opposite sign and multiply these two, and then the last term is squared and always positive. Oh, look at what just happened. This x squared minus 2x plus 4 in the top and x squared minus 2x plus 4 in the denominator are going to cancel. Now, I'm going to show you something that students do sometimes that is wrong. They go, this cancels with this cancels with this cancels with this. That is not the way it works. You need the entire expression being multiplied to cancel. So I'm going to come back here. And how you need to cancel is this entire expression cancels out that entire expression. That is how you need to do it. And then we have this x minus 7 over x plus 2. And in this particular case, this denominator, you can't let x be negative 2, and that was the only restriction to begin with. So I don't have to qualify that x can't be negative 2. You can, it won't hurt anything, but I know by looking at the denominator, x can't be negative 2. And that was the only restriction of the domain in example 4. So this homework going smoothly depends a lot on being able to factor correctly. So then we have division. And you need to know when you divide, you multiply by the reciprocal. So here we have division of a fraction by c over d. So instead, you multiply by, you got to flip that fraction. You multiply by the reciprocal. So what you're going to be working at is going to look like, here's this. Instead of division, we are going to take that second fraction and flip it and make it multiplication. Instead of dividing, you multiply by the reciprocal. You flip it. So you need to look for those division signs and know to multiply by the reciprocal. And then, use the factored forms, and don't forget to look at the original problem, which in this case, that original problem had an x plus 1 and a 2x divided by 2x minus 3. And so x can't be 3 halves. And also let a, b, c, and d with expressions where b, c, and d are not 0. So what's interesting in this is this also can't be 0, because when you divide, you end up multiplying by the reciprocal. And so all three of those terms have to have x values that are eliminated from the end answer. So on this one, the domain is all reals except x can't be -2 or -1 or 3 halves, because all three of those cannot be 0. Excuse me. And so when I look at the end simplification, I can see that x can't be -1. I can see that x can't be -2, but I've lost. I can't just look at that end simplified answer and see that x can't be 3 halves. So you have to include that as part of your answer, so that your entire answer is the simplified version plus that x value that can't be included that we can no longer tell. So in example 5, you're going to end up multiplying by the reciprocal. So you copy the original. You start with an equal sign on the next line, on every line as you work down the page. And you look at factoring the numerator or denominator, and I can take out a 3. And then you are going to multiply by the reciprocal. And I have an 11x over 3 times x minus 3. And since they're being multiplied, I'm just going to keep on going. The x squared minus 8x plus 15. Two things that multiply to be 15 but add up to a -8 are x minus 3 and x minus 5. And so now we have x squared minus 5x, which is going to be x times x minus 5. And you have to think about the domain in terms of whatever made that 0, whatever makes that 0, whatever makes that 0 are not part of the domain. And so on the domain on this, it is all reals except you've got 0, you've got 5, and for the 3x minus 9, it can't be 3. And x squared minus 8x plus 15, it can't be 3 or 5. They had some of the same factors. So the domain is all reals except for 0, 5, and 3, and that takes care of everything that makes the things that were highlighted in green 0. So now as I go down to solve this, I'm going to start canceling. I see this in the numerator as 4 things being multiplied, and the denominator as 4 things being multiplied. And so this x minus 5 cancels with this x minus 5. This x minus 3 cancels with this x minus 3. And then this x cancels with this x. And that whole entire thing is simplifying to just being 11/3, which you can just leave it improper, 11/3. However, we don't even have a variable left. And so you just need to mention, even though there's not there's no variable left, so we don't really necessarily have to say x can't be 0, 5, or 3, because there's no x value in there to plug anything in. Irregardless, this is going to simplify to 11/3. And so there is no variable in there, so therefore we'll just go ahead and leave that out. Example 6. Here's one where you need to realize I'm dividing, but you need to think of this as that quantity over 1, so that when you go to multiply, you're multiplying by 1 over that 2x squared plus 2x. And in that first one, we need to factor this out. And the denominator already is just a product of two things. There's nothing to factor there. And 6x squared plus 4x minus 2. Well, wait a minute. They all have you have a 2 you can take out. So let's go ahead and do that first. And that means I'll have something that's maybe a little bit easier to factor. So take out the common monomial factor of 2. And then think about how that's going to factor. And I'm going to need a 3x and an x. The end answer has to be a minus 1. So if I put plus 1 here and minus 1 here, that'll give me a positive 3x and a minus x, which is a positive 2x. So I get that middle term to be correct if I multiply those out. And then in the denominator, I have 5x squared times, I can pull out a 2x, and I have an x plus 1. So now as I go to cancel some things, the x plus 1 cancels, and this 2 can actually cancel with that 2, and I end up with 3x minus 1 all over 5x squared times x, which is a 5x cubed. But now I need to go back and think about what things made this 0, which is x being 0, which if I look at this, I know x can't be 0, so that's obvious. But also, what things made this 0? And that factored into that 2x times x plus 1, which again, x being 0 makes it 0, but so does a negative 1. And I can't see that within this end expression, so I need to say x cannot be negative 1. And there is my solution to it. So, depending on how good you are at factoring, that will play a big role in being able to do the assignment more quickly. And if you still need opportunities to practice factoring, this is going to take a little bit longer, but you need more opportunities to factor, and here it is, because the expectation is you can factor trinomials. So give yourself enough time so that you can work through it, and especially if you know you need some help with factoring. Don't take shortcuts because you need to be able to factor. And there you have it.